The chip inside your phone is smaller than a fingernail. On it sit over 15 billion transistors. Each one is roughly 3 nanometers wide, about the size of 15 hydrogen atoms placed side by side. And every single one was placed there deliberately in a process so precise that a single speck of dust would destroy the entire thing. What you're holding in your pocket required the most complex manufacturing process humans have ever invented. Here's how it actually works. It starts with sand. Ordinary beach sand is made of silicon dioxide, and silicon is the base material of almost every chip ever made. But not just any silicon. The silicon used in chip fabrication has to be 99.9999999% pure. 9 nines of purity. To get there, raw sand is chemically refined into polysilicon, then melted at over 1,400 degrees Celsius and slowly crystallized around a seed crystal into a single, perfect cylinder called an ingot. That ingot is then sliced into wafers, discs roughly the size of a dinner plate and less than a millimeter thick. The surface of each wafer is polished until it is optically flat, and not approximately flat. Flat to within a fraction of a nanometer across the entire disk, this wafer is now a blank canvas. What happens next is called photolithography. And it is this step that defines everything. A light-sensitive chemical called a photoresist is applied to the wafer surface. Then a machine called an extreme ultraviolet lithography system, built almost exclusively by a single Dutch company called ASML, shines a specific wavelength of light through a stencil called a mask. This light etches the circuit pattern into the photoresist, exposing the silicon beneath in precise shapes. The wavelength of light used is 13.5 nanometers, far shorter than visible light generated by firing a laser at a tiny droplet of molten tin 50,000 times per second and collecting the plasma flash that results. This process is repeated dozens of times, layering circuit patterns on top of each other with nanometer level alignment. A single misalignment ruins the chip. After each exposure, the wafer is chemically etched to remove exposed material, then doped, a process where specific atoms like phosphorus or boron are implanted into the silicon to alter its electrical properties in precisely defined zones. This is what creates transistors. A transistor is simply a switch. It either allows current to pass or it doesn't. At 3 nanometers, you can fit billions of them in a space you cannot see. The entire logic of computation, every calculation, every pixel, every decision your device makes, reduces down to billions of these switches turning on and off billions of times per second. Once all the layers are complete, the wafer is tested, each chip printed on the disk, and there can be hundreds per wafer, is probed individually. Chips that fail are marked. The wafer is then cut into individual dies using a diamond saw, and the failed ones are discarded. The surviving dies are packaged, connected to a substrate with gold or copper wires thinner than a human hair, sealed in a protective casing, and tested again. The entire process takes roughly 3 months from blank wafer to finished chip. It takes place inside a clean room where the air is 1,000 times cleaner than a hospital operating theater. Workers wear full body suits not to protect themselves, but to protect the chip from them. A single skin flake, a single exhaled particle, is large enough to bridge 2 transistors and short circuit an entire layer. The factory that does all of this, a semiconductor fab, costs between $10 and $20 billion to build. It requires a dedicated power grid, an enormous water supply for cleaning, and supply chains spanning dozens of countries for the chemicals, gases, and equipment involved. Only 3 companies on Earth can currently manufacture chips at the leading edge: TSMC in Taiwan, Samsung in South Korea, and Intel in the United States. Every time you unlock your phone, you are holding the output of the most precise manufacturing process in human history. And it started with sand,